All right, greetings, kids. Today we're going to talk about the science of work, specifically what it is and what it is not, what it isn't. All right, so let's move forward. Work is based on two things. The amount of work done on an object depends on two things. Got any idea? Can you name them? We've talked about this a little. Something has to move, all right, so distance is a part of it, and there has to be force applied. So how much work is done on a thing depends on distance and force. In science, we use spring scales to measure force, all right? You've seen these in the grocery stores. They will measure weight. Remember that we measure force with a unit of measure called the Newton, and the Newton lines up with the metric measurement of mass, which is so that 1 Newton equals 100 grams. And on this picture you can see why we call this device a spring scale. It's actually got a spring loaded there in the back. You can see in that picture. Now, let's get into the details here. No matter how much force you apply, if you don't move an object some distance, you don't have work. Okay? So if you've got force and no movement, that means no work. No work is done. All right? So the little green man there, he's pushing on that object, it's not moving. So there's no work. If you have force and movement, then you have work. So the little green man pushes on the red and orange object, it moves, now we have work. So let's take a look at some examples. Here's the formula, all right? Now we're getting into math even. Work equals force times distance. Okay, that's why we say work there involves two characteristics, force and distance. So consider the following problem. If an elephant pushes against a wall with the force of 10,000 newtons, a lot of force, but the wall doesn't move, how much work is done? So let's plug this into a formula. If work equals force, which in this case is 10,000 newtons, times distance, which in this case is 0, then we've got 10,000 newtons times 0. Anything times 0 is 0, right? So we have 0 units of work. 10,000 newtons of force, a lot of force, but no work because there's no distance. Now, if an ant pushes a grain of sand with the force of only 1 Newton, but moves that grain of sand 1 meter, then how much work is done? So let's look at the math. If work equals force, which is 1 Newton, times distance, which is 1 meter, then we have 1 Newton times 1 meter, that's 1 times 1, which is equal to 1 unit of work. Now we've talked about in prior discussions and over your vocabulary that the way we would measure that would be the joule, J-O-U-L-E, but we're not going to go into that right now. So who did more work? Well, ironically, the ant, because there is distance. Only 1 Newton of force, but 1 meter. There you go. You've got distance. Therefore, by the definition of physics, you've got more work happening with the ant than the elephant. Now, there's our formula again. Work equals force times distance. Let's try some examples involving ramps. Example A, we've got 180 newtons of force required to lift a box straight up 1 meter. Example B, we've got 60 newtons of force required to move the box up the ramp. All right, so it takes 60 newtons just to move it at all. Okay, and the distance that it's going to go to get to that 1 meter is 3 meters. All right, so the force is spread out. It takes less force, but there's a longer distance here. So if we apply the formula, which example requires more force to move the object? Is it A or B? So we plug in the formula and we answer our question. Example A, we've got 180 newtons of force. Example B, we've got 60 newtons of force. So which example requires more force? A has more newtons, more force. All right, pretty straight ahead. Pretty simple. Let's try another question though. Same examples. Which example produces more work, A or B? And to answer that, pretty simple really, but let's plug them in to the formula, the work formula. Example A, we've got 1 meter times 180 newtons. That's 180 units of force. Example B, we have 3 meters of distance and 60 newtons of force. So you multiply those. 3 times 60, 180. So A and B are each 180. They produce equal amounts of work. So work is force times distance. And if distance is 0, then work is 0. End of story. Let's make it simpler. Okay? Let's just boil it down. Work is force times distance. If distance is 0, then work is 0. Anything times 0 is 0. Simple enough. End of story.